Here we are, question 24 of the Functions and Graph, Chapter 2, Year 2. Given a function p of x minus 2 modulus or absolute of x plus 4 plus 10. What is the range of p of x? So, let's have a thought about this. If we are dealing with x plus 4, okay, we would have a line that comes through here. It'd be a nice positive line. It'd be at 4. It'd be at 4. Nice big positive line like that. Okay, something like that. Anyway, if you take the modulus of that 4 point here would be jumping out like this as well. Okay, because it'd be bouncing off. If we then decide to multiply it by minus 2, that v that's cutting through 4 and is hitting minus 4 down here would suddenly become something like this, okay, upside down in its work. Okay, so it's there. So that's all of the minus 2 modulus x plus 4. Okay, it would also narrow up a bit, being with the plus 4 there. And then when you add 10, it would take that point there and it would shift it up by 10, giving you the final score, which means this point here must be 10. Okay, so we can state the range as being p of x is less than or equal to 10. Another way of thinking about it is, if we know these 2 points, then we know it's a symmetrical graph, and as such we'll be able to find the point there. Okay, and find that middle point and sub it in to find where that top is. So if we take both equations, which would be setting it equal to 0 and saying 0 equals minus 2x minus 8 plus 10, then bring that across. That's a 2 minus 2, x equals 1. So that point is 1. Okay, and if we do it again for the negative, so we get 2x plus 8 plus 10. Okay, 18, bring it across, 9 minus 9, and that point is minus 9. Gap there of 10, which gives us a point here of 4, which is what we were talking about when we were doing the x plus 4, sorry, minus 4. Okay, and if you do p of minus 4 in quickly, okay, we should get minus 2 modulus minus 4 plus 10, and of course that gives you minus 2 modulus of 0 plus 10. There's the 10. Okay, so that's the range of p of x. Right then, inverse p of minus 1. What is the inverse p? Starting off first with the line y equals x, and we now need to rotate that graph or reflect that graph in it. So we would actually get exactly the same sort of line coming through there, be at a slightly different angle, but ultimately we're going to end up with a graph that looks something like that. I'm not quite sure where it's going to land down here, I suppose. Okay, with that at 10. So that's what p of minus 1 would look like. I get a result here, I get a result here. It's a 1 to many result. So p of 1 does not exist because it would be a 1 to many graph, so not a function. Okay, excellent. Let's see. All right, so solve p of x greater than minus 4. So again, there's going to be a point here where we are getting minus 4, and that will give us presumably 2 results in there, okay, which we can then try and find. So let's go put this in. Okay, so we're going to start with minus 2 of x minus 8 plus 10 is greater than minus 4. We're also going to be looking at plus 2x, i.e. multiplying minus 2 by minus x. Okay, minus 4 times minus 2 is plus 8, plus 10 is greater than minus 4. 2 things to solve there. So what do we have then? We've got minus 2x is greater than, what's that? That gives me 2. Bring 2 across, minus 6. Okay, and so x is, watch out for the change of the greater than less than. Okay, 3. And on this one, 10, 18 coming across minus, so 2x is greater than minus 22, so x is greater than 11, not 11, minus 11. Okay, and so we have the final answer there of minus 11 less than x less than 3, which makes sense that when you draw the line across here at minus 4, then there's your 3, there's your minus 11. Okay, it's fitting roughly with what we expect to see. Okay, next part of this question was p of x equals minus a half x plus k. State the range where k has no solution. So minus a half x would be some sort of quite relaxed line coming through, and as you add a k to it at some point, it's not going to touch the graph, or it's not going to come across and hit both things. Okay, so we want to know where it is just touching up there, don't we? And since we know that maximum point is up here at 10, okay, we might be able to use that to our advantage. Okay, so state the range where k has no solution. So we know already that that is at x equals 4. Okay, so p of x not 4, minus 4. P of minus 4 is equal to 10, and that's the maximum. Okay, so when we have an x equals 4, I wonder what happens to get a 10 in there. So if we have 10 equals minus a half of 4 plus k, then we end up with 10 equals minus 2 plus k, and 8 equals k. State the range where k has no solutions. It would be when k is greater than 8, because when it is equal to 8, it does have a solution. So greater than 8, it doesn't have a solution. Okay. So yeah, helped out greatly by the fact that I found where the 4 was in there, and we could have it come across like that. Okay, any other ways we could do that? I suppose we could just put it all in and look for it, but that should be okay. Right.